All right, guys, thanks for coming. It's a Crypto 101 call. Today, we're going to be talking about blockchain basics. And I want to get into proof of work versus proof of stake. So just to start things off here, let me share my screen. Start things off here, looking at the market as a whole. We have been going up for like the last 2 weeks now. Bitcoin's hitting 9,700. I'm going to show you on TradingView after this. Ethereum's at 700. Ripple's almost at $1. Litecoin's at 165. Cardano's 30 cents. Stellar's at 40 cents. A lot of green here. A lot of green. Tron's up 26%. Seems to be the biggest winner up here. But yeah, I was just seeing a lot of green across the board. We are experiencing nice little bullish retracement on the overall bearish trend of this market. So that's pretty chill. We can look at Bitcoin here on the chart, see where it's at. I can also show you give you my bias relating to recent events. Okay, yeah, here we go. Here's Bitcoin. So I have 10K marked out here as a huge level. And even for me, I will remain bearish pretty much until I see this price level of 11,750 right here broken. This is the previous lower high. And this is the high that I want to see broken before I'm willing to say this is bullish. This market is bullish again. I'm really interested to see what price is going to do when we get to 10,000. We've cleared 9,000 with a lot of momentum. I do think we'll get up to 10, touch 10. As long as we stay, we'll see right here, 9,500 could serve to be support going forward. So that's the technicals on Bitcoin. That's just updated the market where we're at today. And now let's get into what we're here for, which is Crypto 101. I'm going to try to explain how the blockchain works for you guys. So this is some basic stuff. Blockchain was created, the blockchain was created by Satoshi Nakamoto in January of 2009. This is right after the economic recession that we saw. Why did he create this? Well, Satoshi saw a world that we lived in where inflation was controlled by a central party. It was controlled by the Federal Reserve. They were the ones that enabled to print more money to bail out these banks. And why were we trusting these parties, which have shown on the record countless times of manipulation through the interest rates? Oh, the Congress ain't gonna print more money. So what he wanted to do was take away that trust in that third party. A lot of people argument against Bitcoin is, oh, it's not backed by anything, it's just computer money. Well, I counter argue, what is gold? What is US dollar backed by now? It's not backed by gold anymore. This is back from the early 20th century that was removed from the gold standard. So most currencies, the value is only what people give it. The reason the US dollar is valuable is because people give it value. So he had an idea of creating a currency that couldn't be manipulated with, by the banks, by the governments, that the interest rate was controlled, fixed, transparent, that everyone could see and understand. Hence the blockchain. A little something about Satoshi. Nobody knows who he is. This guy created code. There's lots of emails, history between him and some of the lead developers, including Gavin Andresen, and a few others. But at the same time, nobody knows who this guy is, and he still hasn't been found yet. Let me get in. Craig Wright came out and said that he was Satoshi. This was proven as false. I think we might not ever figure out who Satoshi actually is, and I kind of think he wanted it to be that way. The system he created is so genius in the sense that this is a way for people to securely and openly store money and exchange value on the internet. Like the internet revolution brought us the ability to transmit information anywhere in the world. No longer does it take you 3-4 weeks to send a letter from Chicago to Japan. I can send an email to someone in Japan, they could be reading it 5 minutes later. So why can't I send someone in Japan money at this point in the world? If I want to send them money through the current tech that we have, through the current institutions that run our financial system, it's going to take 3 to 5 days for the ACH processing system to process this payment. Why is that? We live in 2018. The internet is so powerful. How can we change value on the internet? And then that comes to the question, if you want to exchange value on the internet, who is going to be the party that enables this trust between me and whoever I want to exchange money with? If they don't trust me and I don't trust them, no one's going to want to be willing to pay. So the whole geniusness of the blockchain is creating trust through code, through a protocol that everyone can see, that everyone's transparent. That gets me into what is the blockchain. Oh, I just want to mention there have been previous attempts on digital cash. There's one called DigiCash. It was made back in the late 90s. So this idea has been around for a while, and PayPal, even in the earlier days, were testing not cryptocurrencies, but digital cash versions. Cryptocurrencies are new, and that's what we're in the market of. That has to do with the cryptographic functions that secure this blockchain. That we'll get into later. So basically, what is the blockchain? From what I said, it's basically the best way I can describe it is we all know it's a distributed ledger. It's an account records of everyone's money on the blockchain, who holds it, who they transacted with, and when. It's distributed ledger, so every single person on the network has a copy of this ledger on their computer that they all can see. It's essentially a source of truth for history. So the implications of this are insane. I still remember this day. I watched a video on YouTube in early November last year, and it was basically breaking down the blockchain. I had heard of Bitcoin, I've heard of those kind of things, but never have I understood like essentially what the blockchain is. And that video broke it down for me, and it just clicked in my brain like, holy cow, we exist in a world where there's so many businesses and parties and things that just exist to facilitate trust between people. Why do we need those things? This technology is literally the way around that. We can all post it. We have internet devices. Everyone's got a laptop, a cell phone, a computer. We can all use a ledger from that internet that's on everyone's devices and just send it through there. So the implications of blockchain and distributed ledger technology, I mean, the one, you have banking. Why do you need a bank to verify that you have the funds? Why do you need a bank to interchange these funds? When I can just, hey, you can see my Bitcoin wallet. I can see your Bitcoin wallet. I'm going to send you this. We'll post it to the Bitcoin network, which you know is secure. Someone will verify it, and we'll get our money. Banking is essentially, that's the biggest industry that is threatened by this technology. Second, real estate. Why do we need realtors and brokers anymore when I can just simply, I can look, there's an actual coin called Proppy. There's a few others, but essentially it'd be like an eBay and Amazon for real estate. I can go on there and look, find a house, I want to buy it, pay for it. I have everything verified, and then the contract of the house will be written in smart contract form on Ethereum's blockchain. So real estate, medical records, supply chain, any marketplaces where things are sold, advertising, just the whole idea of getting rid of these third parties that make money based on other people using their services, when those services could be essentially code and software that everyone can use and everyone can improve upon, and they're open source. Everyone's available to use it. That's why they're called decentralized ledgers, because there's no central figure controlling how the ledger works, which removes a lot of corruption. That leads me also to the idea of voting. You can have voting take place on a blockchain. No more will we have these weird, fraudulent voting results where someone's like, oh, we lost the ballots, or how does that even happen, right? Having voting done on a blockchain would mean everyone submits their votes to the blockchain. It's all verified, and nothing can be changed. So how the blockchain works is, and it's basically record keeping. And how this record keeping works, I say I send a transaction to you, Ryan, and Ryan, you send one back to me. When I send a transaction to you on the proof of work model Bitcoin has, we'll use that as an example first. The miners on that network are going to make sure, hey, he has enough money. Hey, Ryan has got the money. All right, transaction is done, secured. Let's write it on the block. And each block contains a lot of transactions, fixed amount of transactions. There are a lot of technical specifics about that. Bitcoin Cash, Litecoin are different versions of how big the block should be, because how big the blocks are determines how fast the network can be run and how efficient it is. But going back to the basics, when we send that transaction and it's verified and posted to the block, this block is then cemented. It's sealed. This block has been verified, and whoever mined that block is going to get a reward for it. This should go to probably I'll probably go until like 7:30, 7:40, however much time I got. So once these things are mined on the block, once these things are verified, the block is then mined and it's sealed. This block cannot be altered with anymore. And the next block that is done, next transaction is verified, is another block on top of this block, and so forth and so forth. That's why it's called the blockchain. And in order for me to change a block in history and previous, like if I wanted to say, no, I didn't send that money to him, even though I did, like stealing my money, so to say, I would have to change all the blocks that had been posted after that one in order to change that original block. You can see the security of it. This is basically an immutable ledger. And also, I would have to go into the network of every single person who has the blockchain network on their computer and change the record on their record too. Like, everyone has the record of what's happening. It's fully transparent. And this technology is awesome, guys. I love it. If you guys have any questions about it, just let me know, like how it was more, like how the blockchain works, that kind of things. But what do I want to get into? So now it's like, how do we agree upon things that are posted on the blockchain? Let's say I send Ryan a transaction and he sends me one, he disagrees and he says one thing, I say it's another. Or so like a different verifier who's mining our transactions has a different thing. Or someone wants to be a bad actor. Someone wants to rewrite history in the way that it really wasn't. How do we establish the correct things to be posted on these blockchains? That is called, what blockchains have called, the consensus protocol. And each blockchain essentially has their own version of the consensus protocol. Consensus is simply a way to agree on what is posted to the blockchain. Without it, anyone could post anything and no one knows what would be right. We have to have an organized fashion of how we're going to agree upon what is posted to these blocks within the blockchain. And that is the consensus protocol. Each one has their own. And what I want to get into now is proof of work, which is what Bitcoin is based on, and proof of stake, which is the best alternative given so far. What I mean by what's posted, so when we conduct a transaction, that transaction needs to be posted. Then the transaction needs to be like written down and recorded on the blockchain. Once the money moves, it needs to be recorded, like this is the accounting of this transaction, so to say. So that's what I mean by posted. I mean that that it's posted to the ledger. It's posted to the blockchain. That record of I sent you 2 Bitcoins. All right, write that down onto the blockchain. That's what I mean. I hope that answers your question. So now back to proof of work, proof of stake. These are our consensus protocols. This is how we establish that things are right, that we're agreeing upon what's being written to the blockchain, what's being posted. So proof of work is what Bitcoin runs on, and proof of stake is the best. As probably, how do I say this? Proof of stake is basically an upgraded version of proof of work due to the inherent problems proof of work has had. Proof of stake is the upgrade to proof of work. So what's the difference? Well, actually, let me explain proof of work first. So proof of work is your traditional model of consensus on a blockchain. This was the original version of proof of how things were posted to the blockchain. Proof of work came out in 1993 to combat spam emails. So the idea is the consensus between many nodes equals a secured blockchain. The more people mining, so what mining is, if me and you, like let's say we're going back to this example of our transaction between me and Ryan. I sent a transaction to Ryan, he got it. How this network works is in order for me to validate that transaction on the blockchain, in order for me to give it the stamp of approval to be posted, I have to be a miner. And what miners do is miners use computer power, and they are using the computer power to race to solve a cryptographic hash puzzle. Everyone who has a computer can run these, everyone can mine. And Those who are trying to solve the puzzle are called the miners. So there's a race to whoever solves this puzzle first. It's just basically this puzzle is cryptic. You're trying to solve a puzzle, and the more computing power you have on your system, the more likely you are to solve this puzzle. Once you solve this puzzle, you are then given the right to validate the transaction on the block. You won the mining race, and then you get a reward for mining so to say. That's the mining reward, is you get Bitcoin. So in order for the network to be secure, we need people putting in their computer power to want to verify these transactions. People who verify these transactions then are rewarded. There's an intrinsic reward to be someone who verifies a network. More people doing this, more people racing to solve these puzzles, the more people that want to verify these transactions, the more secure the network becomes. So the more miners you have, the better, the more secure the network is. These are the people that are putting their computer power right now to verify all the transactions on the network are legit. So if they're verifying that they're right and they have the most computer power, they will then if they solve the puzzle, they get the reward. So what mining, the problems with mining are, back in the day, when Bitcoin software first came out, you could run Bitcoin software on your computer and you could have mined probably a good stack amount of Bitcoins back in 2011, back in 2012 on your own PC with just the computing power you have there. Now it's become so popular. Everyone does, it's so well known, and it's very, very hard to win these hashref puzzles. So in order to actually use your computer, to actually be able to have a chance to mine a Bitcoin is extremely, extremely competitive at this point. There's things called mining farms, where basically it's a group of people with a bunch of money that set up an entire farm with a building of just computer rigs to mine these Bitcoins. There's high competition, and not to mention the energy needed to run these computing power. So essentially, we're having a lot of people just spending a lot of money and electricity on running their computers to try to mine coins on the blockchain. And that essentially is extremely inefficient in the sense that when you have all these people racing to solve the same block, the electricity that's being used right now, I have a stat, it was as much as the country of Denmark needs to run, just being used for people to race to verify Bitcoin. So there's a lot of wasted energy using the proof of work in order to verify transactions. Proof of work is more rewards to CPUs with higher hash rate. So if you have better equipment, more money, you're going to be able to verify more transactions, get more Bitcoin. And then the last problem with that is mining pools. Is that basically you can take a group of people's computers, take their mining power, and put it together, and you split the rewards you'd get from that. And so these pools are becoming dangerous because if there was ever a pool to succeed 51% of the network hashing power, they basically are the main validators now. They control every single thing. They have 51% control. They can rewrite history. So this hasn't happened yet, but that is you'll hear that before. It's called the 51% attack. And that is the power, that's a problem with proof of work, is that it's becoming centralized because these groups that are mining, the only ones that are verifying basically the security of the network, are becoming smaller. The competition's so high, so the groups that are actually doing this mining is becoming more centralized and more control. There's a very interesting topic of that goes into Bitcoin Cash, about when Bitcoin and Bitcoin Cash forked. It was due to a scaling. So we all know these blocks are big and hard to verify, and some their transactions built up and they backed up. We saw that in December. So we've been looking at scaling solutions for Bitcoin, and Bitcoin Cash is actually literally just a fork of Bitcoin because they didn't like the scaling solution. And it had to do with the sense that Bitcoin Cash is easier to mine, and the mining controls can keep control of Bitcoin Cash. That's a whole nother side topic, maybe next Crypto 101 call. But now getting into proof of stake. So proof of work uses miners to validate transactions. Proof of stake uses validators. Proof of stake was created in 2007 was proposed in 2007 by Bitcoin forum talk by a user named Quantum Mechanic. He proposed this idea. He basically said, competition to mine transactions, competition to verify a network is useless. Why are we competing to verify things? That was the whole efficiency of having centralized institutions that verified trust. It was efficient. You needed just one person to say, yep, this is good. Why are we competing to validate things? That is a waste of energy. It's just an inefficient process altogether. So the solution to proof of work is proof of stake. Can anyone verify? Yes. On proof of work, anyone can run mining, and you can start mining and start verifying. In order to actually verify to win, you'd have to have a lot of hashing power. So the likelihood of you ever getting rewards from mining is very low. So proof of stake, not anyone can verify. That's the difference. Basically, how much you stake is how much you can receive. So if I wanted to be a verifier of this blockchain on proof of stake, I need to stake coins I have in this company. I need to, and most coins set a minimum. So I literally need to throw down my money, my capital, my financial incentive to be a part of this network. In the sense that I'm not just proof of work. Miners don't have anything on the line. They're just competing against each other to verify transactions to receive Bitcoin rewards. Proof of stake, I'm putting my stake of the company essentially on the line to say, yeah, I want to be a validator. I want to be a part of this network. And there's a direct incentive for me to do so because proof of stake and proof of work, when a block is posted, the result is they receive Bitcoin. A new Bitcoin is mined. That's how the new Bitcoins are created. Proof of stake models, the amount of coins is fixed. There will never ever be any more coins. So the proof of stake validators, you're asking, well, what's the point of being a proof of stake validator? Why should I validate the network if I'm not going to be rewarded? Why should I put my incentive down, my money down, my stake in to validate things when there's no direct reward? But there is. So what happens on proof of stake is the proof of stake, whoever validates a transaction, is rewarded with the transaction fees on these networks. That's another whole thing of how the coins are actually used as transaction fees. But let's just say there's still a reward to be a proof of stake validator. You will be rewarded with the coin when you validate transactions. It's just that you're not creating new coins. You're just getting coins that were used as transaction fees. That's how the miners are paid. They're not miners, they're validators. That's how the networks, the people who keep the network secure, the validators, that is how they're compensated. Where on Bitcoin, they're compensated by mined new Bitcoin. Proof of stake, they're compensated with the transaction fees used to run the network. So how to become a validator? You have to stake a certain amount of coin. Validators, so basically every time there's a new block to be verified, to be posted, every time there's a new block, there'll be pretty much a random selection of the validators. If I validated 1,000 coins, Ryan validates, or if I stake 1,000 coins, Ryan stakes 10 coins, and Caleb stakes 1 coin, I have way higher chances because I've staked more. So it is linear related. It's not completely random in the sense it's linear related with how much you stake, how likely you are to be someone who validates transactions. Yeah, size of your stake determines the chances of validating the next block. This might seem not fair because obviously you can say that rich people are just going to get richer. Whoever has the most stake is going to get the most coins. It actually is more fair and less decentralized in proof of work. So in proof of work, due to economies of scale, the more like CPU resources and the more energy you buy, the cheaper it actually becomes. Versus proof of stake is directly linear. How much I put in is how much I'm going to get out. Proof of stake, there exists by economies of scale, in the sense that you can have enough money and have enough capital to get beyond the curve, and you're actually making more money just because you have more money. It's not like that in proof of stake. Okay, when no transactions are verified block, they receive verified. Yep. Transaction fees. Okay, so how does it stay secure? In proof of work, everyone's racing. Proof of stake is just you have to have stake. So let's say I have a big stake and I decide not to verify my transaction, or I decide that I'm gonna try to do something fucking. I'm gonna try and change the record, and I'm gonna try and make it to my benefit. You know, I want to rewrite that I didn't pay that coin so I can get my coin back. If you act fraudulently, or you don't show up to validate, you will be removed as a validator. So there are consensus mechanisms, there are voting mechanisms worked, and this goes into delegated proof of stake, and there's phasing fault tolerances. So proof of stake has more sub-mobs within it on how these validators, the people who are staking their coins, how they are chosen to be the validators of the network. There's different mechanics and different networks. I'll show you here in the crypto catalog. So let's see here. Too far down. So for example, our big Bitcoin, Litecoin, Bitcoin Cash, all proof of work. Ripple is proof of stake. They have something called practical biasing fault tolerance. This essentially means their validators, their people who have staked are pre-selected. And there's another one called federated Byzantine agreement. This one is more democratic in the sense that people are actually voting on who are the people that are going to be validating these transactions. How's it going? So each network basically has their own mechanics of how they want to do this. Let's get into more of proof of stake. Some examples are Lisk, Cardano. As you can see on my catalog, I actually have outlined pretty much all of the coins that run this proof of stake model. And this is why I'm trying to explain this in this video, because I think it's very important to understand the differences between proof of work and proof of stake and which one, the advantages each one's offering, the disadvantages. So let's get into that actually. So what proof of stake has over proof of work is the advantages are scaling. There's not a bunch of people racing to verify the block. We have predetermined people validating these blocks, which means blocks are going to be validated a lot faster, and overall network transactions will occur a lot quicker because things are happening faster. We're not using the insane amount of energy like proof of work does. It's a lot less energy. There's a lot less energy required to use it. It's just a simple, I think, a better idea. Why would you compete to be the trust when you could just have a plan, basically, a protocol for the trust? Centralization. Anyone can be a validator. Takes a lot of money to be a miner. As I was saying before, the 51% tax. It's going to be a lot more expensive for me to buy 51% of the supply of a bigger coin like Ethereum versus buying a coin like on smaller networks. If you do, you can essentially buy 51%. But for me to get 51% of Bitcoin's network, I would require me to purchase the CPU's powers of 51% of the hashing network available. That would require me to buy a lot of computing power. So Bitcoin is actually, proof of work is more centralized than proof of stake. That's what I'm trying to say. What else do I got for you? Got a bunch of notes. I think that's pretty much it. Does anyone have any questions of proof of work versus proof of stake? Did I explain that well? Some things you want me to go over again? Yeah, that is part of just blockchain technology. Whoever my iPad is, every single blockchain is completely transparent. Actually, it's crazy too because people say blockchain is like a way for illegal drug money to use, but it's stupid if you were to buy blockchain illegal drugs on the blockchain, because you can trace everyone's address back to you can trace the transactions that occur on a blockchain. You can go, you know exactly which address and exactly which other address, exactly how much Bitcoin. Versus if you use just straight cash dollar bills, actual cash dollars are a lot less traceable than Bitcoin transactions are. So yes, you can always see everyone's transactions. Privacy coins like Monero, I have it right here actually, privacy coins like Monero, Dash, Zcash, what they do is they anonymize the address. So you'll still be able to see the transaction, you'll still be able to see if someone sent X amount of Bitcoin, but you wouldn't be able to see who or when. And that is due to that fact. They don't want people knowing who or where they sent money to. Great question though. Some final notes I got for you guys. Something to watch out for: Ethereum. We all know is a big cryptocurrency. Decentralized applications. They want to be the software, the iOS for the new currencies. They want to be that centralized platform. Ethereum, their co-founder, not the founder, their founder, Vitalik Buterin, I probably butchered his name. He has gone great length about the advantages of proof of work, disadvantages, what proof of stake could offer, how could that be beneficial. And Ethereum is actually in the works right now to make a network upgrade called Casper. Casper is their proof of stake model that they are trying to implement. Nice to meet you, Brian. So yeah, that is coming out. I heard it's going to be a hybrid of proof of stake, proof of work. That actually already exists on Dash. So that has to do with one layer of the network would be verified through proof of work, another verified through proof of stake. Another interesting project that's really trying to tackle proof of stake and the scalability and the more decentralized aspects of it compared to proof of work is Stellar, Ripple, another one, Cardano. They have a delegated proof of stake network, peer reviewed. So proof of work is pretty much, it's been done. It's verified. Like Bitcoin's been using it. We all know it's energy. It's very energy inefficient. It takes a lot of energy. It's centralized in the sense that mining pools are controlling the network entirely. And yeah, the energy that is used to create this blockchain, if the blockchain were to ever to scale to everybody in the world using this, proof of work wouldn't be viable because of the raw amount of energy that is required to run it. So that is why you see proof of stake solutions being implemented, being tested. There's no need to have that competition for who's going to be the one to be the trustworthy person to verify. There are more efficient models and ways of establishing consensus. These are the basics of consensus protocols: proof of work, proof of stake. There are a few others out there you might see on this catalog. This is proof of importance. I have not done too much research into that. And like I said, there's delegated proof of stake, and there's proof of stakes with Byzantine fault tolerances. These are more so of how they elect the validators. There's a few more. I think DAG, what IOTA runs on, where is it? Is it completely different than the blockchain? It's a sense that like validators validate other validators, and two nodes need to validate a previous transaction, or you need to validate two transactions before your transaction gets validated. Really crazy. It's a crazy idea. It would solve a lot of the problems that we just talked about for proof of work and proof of stake. But I want to mention that this is just an idea at this point. They don't have any working product. It's not like the proof of work distributed ledger, which has been running for 9 years now and has use cases already in play. Proof of stake just looks to implement solutions to scaling problems of energy consumption, be an overall better version of proof of work, basically. Then a better way to establish consensus on these blockchains. Yeah, I hope that made sense. I know this is a lot of techie things. You think it's smarter to trade cryptos or buy them or hold them? Dude, that's a great question. Essentially, I mean, if you're trading cryptos, you're leveraging them. So you're going to be on the charts looking for highs and lows. You're going to trade like you trade Forex. I think it's easier, I wouldn't say smarter, but I'd say it's easier to buy them and hold them. That's what I do. I have a lot of projects that I'm interested in. I've purchased them, and I'm going to hold them for a good couple of years here. I think we're just beginning to see the innovation of this market really take place. We still haven't seen things really become used in day-to-day life yet. You know, like these projects, these companies could be be very, very valuable in a year's time from now. Bitcoin is a prime example, how much it's gone up over time. And all they're doing is just being just a consensus, like a ledger, accounting ledger, a way to transfer money. All these other ones that want to be a decentralized exchange. There's ones that want to be liquidity providers, decentralized internet, decentralized identity methods, interoperability, decentralized smart contracts. There's decentralized real estate. There's decentralized medical records. There's a ton of different enterprise innovations being developed right now that we haven't even seen been launched, you know? So how do we know what the value of these things really are? I think at this point it's speculative. The market is very speculative. And if you hold on to these coins, especially the smart, like these good projects that will be around, you stand to make a killing. I think that's what brings everyone here. Ripple, I like Ripple. I have some strong opinions on it. Stellar basically was created by the same guy who created Ripple. I think it's a better version of it. Ripple is used by the banks. A lot of different things. I have 1 minute left, guys, so I don't want this to cut off. If you guys want, I can post another Webby. I pretty much went over all the content I wanted to like teach you guys, but I would love to answer questions if you guys have them. This Webby is going to close. I will post another link, so if anyone wants to hop in there and pick my brain, ask me some questions, you can do that. But thanks everybody else for coming. I hope you guys understand what proof of work is, proof of stake now, or at least have a general idea of it, a better idea than you did before. Yeah, until next week, guys. Thanks.